Hello. So I trust that you already have the problems. You've got the PDF of the problems. Let's just start with the first question here. So the mass of a circular oil slick of radius r is, and then it gives us a formula. Okay, so we've got our formula. So here's the picture that I've drawn is this picture of an oil slick, which is essentially just a lot of oil that's dumped into the ocean or into some river, some body of water. And the setup here tells us that the oil slick forms the shape of a circle, right? And we're interested in the mass. So the mass of the oil slick is given by this formula right here. So it's K, and K is a positive constant. I think we can close this now. So K is a positive constant, right? So K is some positive constant. Who knows what impacts K? Probably the properties of the oil, right, that's spilled. Might be an issue of viscosity. That might be something that's a constant that will impact the overall mass. And then R minus the natural log of 1 plus R. So R is the radius of the oil slick. The question here is what's the relationship between the rate of change of the radius with respect to time?
It's 21:30.
So that is the same thing as R prime, right? And when it says the rate of change of the radius with respect to time, so dr dt. And then the other quantity that we're looking at is the rate of change of the mass with respect to time. And that's going to be m prime, okay, which is the same thing as dm dt. So to do this problem, we essentially take our equation that we've been given, our function, right, our equation that relates m and r, and we take the derivative with respect to t of both sides of the equation. And we get m prime equals k times, we need d dt of this stuff, right? R minus natural log of 1 plus r. And then k times, now what is the derivative with respect to t of r? It'll just be r prime. Okay? And now what's the derivative with respect to t of natural log of 1 plus r? Here you're going to actually need to use the chain rule. And you'll get 1 over 1 plus r times r prime. Okay. So that is that question. Now let's move to the second one here. Gasoline is pouring into a cylindrical tank of radius 3 feet. So I can go ahead and get ready to draw my cylindrical tank. So this is my tank. I've been told that I've got a radius of 3 feet. So I can put that in here. Okay. When the depth of the gasoline is 4 feet, the depth is increasing at 0.2 feet per second. So let's see here. So let's just let x equal depth of gas at time t. So that x prime is the rate that, or at which the depth is increasing. Rate at which depth is increasing. And we've been told here that when x equals 4, x prime is equal to 0.2 when x equals 4. And the question is, and this is what we want to know, how fast is the volume of the gasoline changing at this instant? So V prime equals what when x equals 4 and x prime equals 0.2? So this, of course, means we need to add volume as one of our variables. So V is going to be the volume of the gas at time t. And we can go in and we can do a unit analysis. So time t is going to be measured in seconds. How do we know that? because the problem here gives us the units of feet per second for the derivative. Okay, so x prime is really going to be the change in x over the change in t. So the units of the change in t are in seconds, so our time is in seconds, so we can put that here. And the numerator is in feet, so this depth is going to be measured in feet. And that means that the volume is going to be feet cubed. Now, how do we know that? Because the relationship between v and x is volume is equal to pi r squared times height, and in this case, that's going to be the depth x. Okay, so the units for x are in feet. The units for r are in feet, so this is going to be feet squared. So the units for v are going to be feet cubed. Okay. So now we've got our formula here that relates our variables, and we want to find v prime. So what we're going to do, we're going to take ddt of both sides, ddt of pi r squared x. Okay. So on the right-hand side, we'll get pi. Now, we need to do the product rule, right? So if we want ddt of r squared x, that's going to be the derivative with respect to t of r squared times x plus r squared times the derivative with respect to t of x. And so all of this is going to be multiplied by pi. Okay. Now, what is ddt of r squared? That'll be 2r prime. And what is ddt of x? That'll just be x prime. All this is times pi. So, wait a minute. Let's see here. Let's start plugging things in. So we're told that r is equal to 3, because that's given to us, right? Gasoline is pouring into a cylindrical tank of radius 3. So r is going to be equal to 3. What is r prime? R prime is going to be equal to 0. How do we know that? Because the radius of the tank is not changing. The radius stays at 3. So r prime is going to be equal to 0. What is x? X is going to be 4. And then this r squared, that'll be 3 squared. And x prime, we're told, is 0.2. Okay. And so we should have for our v, that v is equal to pi times 0, right? Because 3 times 0 times 4 is just 0. And this would be 9 times 0.2, which would be 1.8. Okay. So that's our answer, is v prime is equal to 1.8 pi. And now let's do units. What units are we looking at? Well, the units of r are going to be feet. So this is going to be feet squared. And the units of x prime were given to us in the problem, feet per second. So this is feet per second. So the units for the v prime would be feet cubed per second. Which, again, makes sense if we look at this as change in volume over change in time. Okay. All right, so there's our final answer. Okay, let's go to the next one. Metal frame of a rectangular box has a square base. Okay, so we can start to draw a picture. So we've got a rectangular box, and it's got a square base. Okay, the horizontal rods and the base are made out of one metal and the vertical rods out of a different metal. So I'm going to use one color for my horizontal rods. So the horizontal rods are here, 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 and here, okay, in the base, whereas the vertical rods are here, 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 and here. So there are 4 vertical and 4 horizontal rods. And the rods are made out of different metal. If the horizontal rods expand at a rate of 0.001 centimeters per hour, so if we're looking at, this means that horizontal rods, let's say X for horizontal. So X prime is equal to 0.001 centimeters per hour. And this is the length, so let's say it equals the length of rod, of horizontal rods. And Y is going to be the length of the vertical rods. Y prime is equal to 0.002 centimeters per hour. So in other words, the vertical rods are growing or expanding twice as fast as the horizontal rods. At what rate is the volume of the box expanding? So we want to know V prime equals what? When the base has an area of 9 centimeters squared, base area equals 9 centimeters squared, and the volume equals 180 centimeters cubed. Okay, so let's add in our variable here for V is the volume of the box. So now we can put in the relationship between V, X, and Y, and it's very simply volume is going to be the base times the height. So the base is going to be X squared times the height, which is going to be Y. Because remember, it told us that it's a rectangular box with a square base, right? Okay, so this is our volume, and we can now take ddt of both sides of the equation. We're going to do the product rule, just like we did in the last problem, and we'll get 2x, x prime, y, plus x squared, y prime. Okay, so now we're told that x prime is equal to 0.001. Y prime is equal to 0.002. Okay, when the base area is equal to 9 centimeters. Because the base is square, if this area is equal to 9 centimeters squared, this means that each length has to be 3 centimeters. Does that make sense? Okay, so this tells us that X has to be 3 centimeters. And now the last, oh, yeah, so we can put that in here. That's 3 centimeters. Well, I'm not doing my units right now, so the last thing we need to know, let me make sure this is clear. This should be 3 squared, right? Because it's squared. The last thing we need is to figure out y, and then we'll be able to multiply everything together and add it. So how do we find y? Well, that we're going to find because we're told the volume is 180. Okay, so the volume is going to be the base times the height. So that'll be 9 times y. So then what is y? Well, if 180 is equal to 9 times y, that means y has to be 20. So y is 20. And that is our answer. So we'll get v prime is equal to 2 times 3 times 0.001 times 20 plus 9 times 0.002. Okay, so now let's do the next one. So point P moves around the unit circle. The angle in radians changes with time as shown here. So note that, so if I'm looking here, it looks like as time increases, theta so theta starts off a little less than 1 and it increases kind of quickly, but then it kind of levels off. So if I were to say what's happening to this point, let's see, it looks like it's trying to reach a limit, right? It doesn't look like it has a limit of limit as t goes to infinity of theta. It looks like this is maybe 6 point something. So I'm actually going to put this at 2 pi. Because if pi is approximately 3.14, then 2 pi would be approximately 6.28, which looks like not that bad of an estimate, right? So if this is 6, it could easily be that this is the limit here is actually 2 pi. So what does this mean for us? Looking at this graph, if I want to see where
it's 21:45.
where is the point as time goes around? Let's see here. Where's pi? Pi is approximately 3.14, right? So pi is maybe here's pi. So if this is pi, right? Now, this means that when t is 2, when t equals 2, theta is equal to pi. So it takes the point 2 seconds to get around. So here's where the point of starting is right here, right? So in 2 seconds, it moves. In 2 seconds, it moves to pi. Okay? And then it moves a little further. Okay? But now, as it starts to reach 2 pi, it slows down. So it's going slower, 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 slower. And it never actually reaches 2 pi, the limiting behavior of P. P is approaching 2 pi. So let's see here. So let's answer this first question here. First question is estimate the coordinates of P when t equals 2. No wonder this point right here, t equals 2, is an important point. Theta is equal to pi, so we're going to estimate that when t equals 2, our point is right here. And what are these coordinates? It's going to be negative 1 comma 0 because we're working with the unit circle. Okay. So to estimate the coordinates when t equals 2, theta is equal to pi, and the x coordinates, x is equal to negative 1, y equals 0. Now, when t equals 2, approximately how fast is the point moving in the x direction? How fast is the point moving in the y direction? So the key to this is to understand what is the x direction. It's going to be cosine theta. What is the y direction? It's going to be sine of theta, right? Since theta depends on t, and x depends on theta, really, x depends on t. And the same thing goes for y. So, if we want to know how fast is the point moving in the x direction, we're actually asking what is x prime when t equals 2. That's what our question is. Okay? And if we know that x is equal to cosine of theta, we can just say x equals cosine of theta. Therefore, x prime is going to be equal to negative sine theta times theta prime, right? And let's rewrite this actually as negative theta prime sine theta, okay? So when t equals 2, what is theta? We said theta is equal to pi. So x prime is going to be negative theta prime times sine of pi. So notice the sine of pi is going to be equal to 0. So negative theta prime times 0, so this is equal to 0, which makes sense because if we look at the position P, pretty much in terms of x, the direction of x in the x direction, this is actually a critical point, right? So P is moving, P is getting close to the x value of P is getting close to 0. And then let me try to show you. Okay, so as time moves, well, let's actually put theta here. So the P value starts off maybe this far, right? What is our x value here? This is the x value. So it's like maybe 1/2, you know. Now, as theta increases, the x value of P is getting closer and closer and closer to 0. So the x value is getting closer and closer and closer to 0. And it hits 0 when theta equals pi over 2. So this is pi over 2. Okay. Now P starts to be negative and moves all the way down to -1. So negative 1 when theta is equal to pi. And then the x coordinate gets closer and closer and closer to 1. Closer and closer and closer to 0. So we're coming back into 0. And this is the curve for here's theta and here's cosine of theta, right? So at this point here, which is pi, we would expect x prime to be equal to 0 because this is a local min of x. Okay, so that makes sense. Let's go back and do part B, or the second part of the question. It's very similar. For the second part, we're looking at y. So y is equal to sine theta, and we want to know y prime, so that's going to be cosine of theta times theta prime. So let's rewrite it, theta prime cosine theta. Okay, and when theta equals pi, when t equals 2, theta equals pi, so cosine of pi, okay, times theta prime equals, now what is cosine of pi? That'll be -1. And now we need to know what is theta prime when t equals 2. So I'm actually going to look here. When t equals 2, theta prime is going to be the slope of the tangent line. So I'm going to do it in a different color here. So I need the slope of this tangent line. Does that make sense? And how can I find the slope? Well, I'm just going to look at, this was in one of the presentations that we had, is to approximate the derivative, the slope of the tangent line, when you're just given a graph. So I will use the rides over 1. Okay, so this is for 2. What happens at t equals 3? So it's approximately here. So that's 3.9. So then the rise, oh, and this is pi. So what's my rise? My rise is going to be How far am I rising? 3.9 minus 3.1, so that's 0.8. And then my run is 1, so my slope is going to be 0.8 over 1. So I put here 0.8 over 1. And then I've got the negative 1. So my y prime I would estimate to be negative 0.8. Okay. All right. So now let's look at this problem. And I think this is the problem that after looking at it, I said, I think that it might be a little complicated. So essentially, you've got a problem where you've got your train is heading west. So here's St. Louis, and you've got a train that's heading west, right? But then you've got a plane that is heading north. The distance between the two, which is what you're asked for, right? How fast is the distance between the train and the plane increasing, right? So you're asked for z prime. But the deal is that because there's 4 feet or 4 miles in between, it's like you've got something that's going this way, right? Your train is going this way. And then your plane is flying this way. If you can kind of imagine this in a 3D world. Okay. So if it's like, here's east, here's west, here's north, and here's south, and here's up, I guess, and here's down, right? Your plane is staying 4 miles ahead, so it's going to be up here, and the train is on the ground, so it's here. So the distance between the two would be from here to here, which requires some, it requires long, complicated formulas. Essentially, this is kind of like what it is. Imagine you're in a box. You're looking at a box here. Oh, not a box like that. So imagine you're looking at a box. And you want to find the distance between this point here and this point here, right? So how do you find that distance? There is a formula, but it's, you can do it with trigonometry because you've got like a couple of, so that right there is, this is 4, this is 4. So you form a triangle from here to here, and from here to here is, if this is X, which is the train, right? So if this is the train, X, and if Y is the plane, so this is Y. Now this base here is going to be the square root of X squared plus Y squared. So now you've got a brand new triangle kind of standing up where this is 4, this is square root of X squared plus Y squared, and now this is Z, right? So it's more complicated. Again, this is stuff that would be from Math 3C. We'll get into depth, learn this in depth and with Math 3C. But for now, we can just skip this problem. Okay, let's go to the next one. Radius of a spherical balloon. So I'm going to draw my picture of a spherical balloon. Is increasing by 2 centimeters per second. So that means the r prime is equal to 2 centimeters per second. R is equal to radius of balloon at time t. Okay. At what rate is air being blown into the balloon at the moment when the radius is equal to 10? So we want to know V prime equals what when R equals 10. We need the formula. So V is the volume of air in balloon at time t. So the relationship between V and R is V is equal to, I need the volume of a balloon, I think that is 4/3 pi R cubed. And we want to find V prime when R is equal to 10. So we just take the derivative with respect to t of both sides. So we'll get 4/3 pi. And then we'll have 3r squared r prime. And now we plug in r is 10. So that'll be 10 squared. R prime, they told us that's 2. So it's pretty easy. Our b prime is going to be 800 pi. And the units will be centimeters cubed per second. Here we go. All right, 39. A spherical cell is growing at a constant rate of 400 micrometers cubed, cubic micrometers per day. And a micrometer is 1/10⁶ meters. So it's a millionth of a meter. At what rate is the radius increasing when the radius is 10 micrometers? So we've got the same situation. We've got a spherical cell. The cell is growing. And so the cell is growing at a constant rate of 400 cubic micrometers per day. So that is equal to V prime. So let's set up that V is equal to the volume of the cell after T days. Okay. We know that the volume is also equal to 4/3 pi r cubed. So
It's
V prime
22
is
hours.
going to be 4/3 pi and then 3 r squared r prime. Now, at what rate is the radius increasing when the radius is 10? So we want to know r prime equals what when r equals 10? Okay, so let's see here. So we go back to our formula here, which says that V prime is going to be 4/3 pi times 3 r squared r prime. But it's also equal to 400, right? Because we're told that the spherical cell is growing at a constant rate. So this means 400 is equal to 4/3 pi times 3 r squared r prime. So now we want to know what's r prime when r equals 10. So if r is equal to 10, and we want to figure out r prime, so we will have, the 3's will cancel out, so we'll have 400 equals 4 pi, that would be times 100. This is times r prime. So it looks like 400 pi times r prime is equal to 400. So r prime is equal to 1/pi. And the units will be 1/pi micrometers per day. So r prime equals 1/pi micrometers per day. All right. A raindrop is, okay, I'm tired. I'll have to finish the rest later.